Algebraic expression. You must have come across simple algebraic expressions like x plus 1, y plus 2, 5x plus 3, etc. Now, how are these algebraic expressions formed? See, we use letters like x, y, l, m, etc. to denote the variables. What are variables? These are the letters which can assume any value. Their values are not fixed. That is, their value can change according to their value can change. For example, I can take x is equals to 2, x is equals to 3, x is equals to 4 or any value. But a constant, that is 400, -7, all these are constants. Constants are those whose values are fixed. That is, the value of 4 is fixed, that is 4. Value of 100 is fixed, that is 100. And value of -7 is fixed, that is -7. Therefore, these are constants and their values are fixed. Now, to form an algebraic expression, we combine these variables. That is, for example, I take x and a constant and combine these two with the help of an mathematical operation, that is plus, minus, division, multiplication, etc. So we can combine these expressions. We can combine constants or variables with the help of mathematical operation, and thus we obtain an algebraic expression. For example, if I take a variable z and add 3 to it, this is an algebraic expression. Now, if I am having an expression 4x plus 5, then this expression is obtained when we multiplied variable x with 4 and then added 5 to it. Thus, we obtain the expression 4x plus 5. This is the expression. That is an algebraic expression. Similarly, if I write 5y minus 9, then this expression is obtained when I multiplied 5 by the variable y and subtracted a constant 9 from it. Thus, I obtain 5y minus 9, which is an algebraic expression. Thus, the algebraic expression is a combination of variable or constant with the help of addition, subtraction, multiplication operation. So, we can also write 5y divided by 9. This is also an algebraic expression where we have first multiplied 5 with y and then divided it by 9. So, we obtain 5y divided by 9. Next thing which we should know is the terms of the expressions. Consider an expression 4x plus 5. Now, in this, we have multiplied x with 4. That is, we have obtained 4x. Then we added 5 to 4x. That is this second term. We have first obtained the first term, that is 4x. Then we added one more term, 5, to this term. Thus, in this expression, we are having two terms. First one is 4x and the second term is 5. Again, if I write 3x square minus 9, then this expression is obtained by multiplying x by x that is we obtain x square. Then this x square is multiplied by 3, so we obtain 3x square. Now we subtracted 9 from this 3x square. So first we have obtained the first term, that is 3x square, then subtracted the second term from it, that is 9. So in this expression we are having two terms. The first term is 3x square and second term is minus 9. Thus the terms are such part of an expression which are obtained, which are formed separately first, then added are known as terms. Such part of an expression which are formed separately first, then added are known as the terms. That is, first we have formed the first part, that is 3x square, then we have subtracted the second part, that is then we have added the second part, that is 9 to it. Let us see one more example. 5x square minus 3xy. Here again we are having two terms. The first term is 5x square and the second term is minus 3xy. So we are having two terms and we have obtained this expression by adding the two terms, that is 5x square plus minus 3xy. Thus the two terms are 5x square and minus 3xy. In this expression, the first term, that is 5x square, is obtained by multiplying 5 with x, and minus 3xy is obtained by multiplying minus 3 with x and y. Now when we have formed these two terms, then we have added these two terms to get an expression, that is 5x square minus 3xy. Again in this expression, that is 3, in the expression 3y plus 9x minus 5, we are having three terms, that is 3y, 9x and minus 5. Now the first term is obtained by multiplying 3 by y. Second term is obtained by multiplying 9 with x, and the last term is minus 5. So the three terms in this expression are, first is 3y, second is 9x, and the third term is 5. Third term is minus 5. Now we should know that in an expression like 5x square minus 4xy, the first term is 5x square and the second term is minus 4xy, which is the correct term and not the 4xy alone. That is the minus sign is included in the term. That's why we are saying that we obtain an expression by adding variables or constant. Now here this is the correct term and this is the wrong term. If we say the two terms of this expression are, so we can say that the two terms of this expression are 5x square and minus 4xy. Next is factors of a term. In an expression 9y square minus 5xy, the factors of the first term, that is 9y square, are 9. Factors of 9y square are 9, y and y. And the second term, that is minus 5xy, has the factors minus 5x and y. Since minus 5xy is obtained by the product of these three terms and 9y square is obtained by the product of 9y and y. Any term is the product of its factor. For example, if I take 3x square minus 5 yz, then this first term is the product of its factors, and its factors are 3, x and x. Now the factors of this term, that is the second term, is minus 5, y and z. Thus, for an expression 4x square minus 3xy, the terms are 4x square and minus 3xy. And the factors of these terms are 4x and x. And the factors of this term is minus 3x and y. Again for an expression 4x cube minus 2yz minus 1. The terms are 4x cube, second term is minus 2yz, and the third term is minus 1. Now the factors of 4x cube are 4x, x and x, and the factors of minus 2yz are minus 2y and z. Now let us see an example. If I have to write the terms of the expression 5xy plus 3xz minus 2x square, then the terms of this expression are first 5xy, second 3xz, and the third one is minus 2x square. Now if I ask the factors of 5xy, then the factors of 5xy are 5x and y. Since 5xy is obtained by multiplying, or we can say by the product of 5x and y. Factors of 3xz are 3x and z. Since 3xz is obtained by multiplying 3 by x and z. The factors of minus 2x square are minus 2x and x. Since minus 2x square is obtained by the product of minus 2 with x and x. Next we should know what are the coefficients. If I have a single term, that is, if I am having a single term, that is 6x square y, then the numerical coefficient of this term is 6. Then the numerical coefficient of this term is 6, or we can say that 6 is the coefficient of x square y. Again, in a term minus 7x, minus 7 is the coefficient of x. In this, we should remember that when the coefficient of a term is plus 1 or minus 1, we usually omit it. That is, for example, if I have to write plus 1x, then I am not going to write it like this. I have to just simply write it as x. This understood that the coefficient of x is 1. Again, if I have to write minus 1x, then I am not going to write minus 1 in front of x. I am just simply going to write it as minus x. It's understood that the coefficient of x here is minus 1. Again, if we have to write minus 1 x square y square, then I'm going to just simply write it as x square y square. Now if we have to find now if we have to find the coefficient of now if we have to find the coefficient of now if we have to find the coefficient of x in the expression 10x square y, then we have to just leave the one x from this expression. That is, we can write it as 10x into y. So we have to write the coefficient of x. So we will leave one x, and the remaining part will be the coefficient of x. That is, if I have to write the coefficient of x in this expression, that is 10xy. That is, the coefficient of x in the expression 10x square y is 10xy. Now in the same expression, if I ask the coefficient of x square, then the coefficient of x square is 10y. Since 10x square y can be written as 10 into x square into y. So leaving the x square part, and remaining will be the coefficient of x square. Now the coefficient of y in the same term, that is 10x square y, is 10x square. Let us see one more example. If we have to write the coefficient of y in the expression 5y square z, then the coefficient of y is 5yz. That is, we have left one y, and the remaining part will be its coefficient. Now if I have to write the coefficient of 5z, then it will be y square. Now next is like and unlike terms. Like terms are those which have same algebraic factors, and unlike terms are those which have different algebraic . Let us understand with the help of an example. For example, I am having an algebraic expression 5x square plus 2xy minus 3x plus 9xy. Then, if I find the factors of 5x square, it is 5 into x into x. The factors of 2xy are 2 into x into y. Now the factors of minus 3x are minus 3 into x. And the factors of 9xy are 9 into x into y. Now here you can see that in the first term, that is 5x square, and the remaining other three terms, nothing is common. That is, the algebraic part, that is x square, is not common in any of the other term. Now if we come to second term, that is minus 3x, here the algebraic part is x, and which is again not same in the remaining part. If we come to third term, that is 2xy, so we can see that xy is common in this and 9xy. So these two terms, that is 2xy and 9xy, are the like terms since they are having the same algebraic part, or we can say the algebraic factors. So 2xy and 9xy are the like terms, and minus 5x and 5x square comma minus 3x are the unlike terms. And 2xy and 2xy and 9xy are the like terms. Now if we are having a term 5pq plus 9q square minus 5q square plus 6p, then in this expression 5pq has the factor 5, p and q. The second term 9q square has the factor 9, q and q. 9, q and q. Then the third term has the factor minus 5, q and q. The fourth term has the factors 6 and p. Now here you can see that the second term, that is 9q square, has the algebraic factors q and q, and minus 5q square again has the factors q and q. Thus these two are the like terms. Now in an expression 5xy plus 3x square minus 3yx, the like terms are 5xy and minus 3yx. Here, since the algebraic factors of this are x and y, and of this term is again y and x, so the algebraic factors of the two terms are same, that is x and y. Therefore these two are the like terms. Now let us see an example. If we have to find that the given terms are like or not, for example, if we have to find out that 4m square p and 4mp square are like terms or not. So first I will write the factors of 4m square p, that is 4 into m into p, and the factors of 4mp square are 4 into m into p. This is having 2 power, therefore it is multiplied 2 times. Here m was having 2 powers, so it is multiplied 2 times. Now if we see, these two terms have same algebraic factors? So we first see that both of them are having m one time, then p again one time, but the third part, that is p and m, is not matching. Therefore these two terms are not the like terms, these are unlike terms. Now if we have to see that minus 7x and 5 by 2x are like terms or not. So we will first find the factors of minus 7x, that is minus 7 into x, and the factors of 5 by 2x are minus 5 by, factors of 5 by 2x are 5 by 2 into x. Now if we see the algebraic part, that is the variable x is here, and in this also the algebraic part is x. So both are having the same algebraic part, therefore these two terms are the like terms.